In this video, we're going to discuss fractions, all right? Before we get to actual fractions, we need to talk about some other parts of numbers. The first thing we want to talk about are factors of a number, all right? When I say a factor of a number, I'm basically saying are looking for the numbers that divide evenly into that given number, all right? And you know, divides evenly means it has a remainder of 0 when you divide it, all right? And so what I want to do is I want to find all of the factors of the following numbers, all right? I have 20 here, all right? So I'm just going to go down my line of my natural numbers and see which ones divide evenly into that given number here, and in this case it's 20. For instance, 1 definitely divides evenly into 20 because 1 times 20 is 20. So 1 and 20 are both factors of 20. 2 goes evenly into 20 10 times, right? So 2 and 10 are factors of 20. If I look at 3 does not go evenly into 20. All right, but 4 does because 4 times 5 is 20. All right, now since I have a 5 over here on this side right here, I know that I'm done with all of my factors of 20 because, you know, 6, 7, 8, 9, and then I'll get back to 10, and I can continue, and I'll get back to 20. All right, so my factors of 20 are 1, 2, 4, 5, 10, and 20. Include the actual number because it is always a factor of itself. Let's look at 36. All right, well, 1 goes evenly into 36, right? So the number and 1 is always going to be in the factor set, right? 2 goes evenly into 36 18 times, right? 3 goes evenly into 36 12 times. 4 goes into 36 9 times. 5 does not go evenly into 36, but 6 does 6 times, all right? So if I want to write my factor set, we can call it a factor set. 1, 2, 3, 4, 6. I only have to write 6 one time since it goes evenly into there. 9, 12, 18, and 36. All right, so those are all of my factors of 36. Now, what I can do is I can write it with some brackets like this. This is just saying it's a set of numbers that are a factor of 36. All right. Now that we know factors, right, those are the numbers that go evenly into the given number, we can talk about what we call prime numbers, all right? And prime numbers are those numbers whose only factors are 1 and themselves. So if I try to write the factor set or try to find the factors of a number, it's only going to include 1 in itself, all right? And so what we want to be able to do is to determine if numbers are prime numbers or not. All right, for instance, 29. All right, I want to think about 29. I'm going to try to divide 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth into 29. All right, if you think about it, none of those numbers besides 1 and 29 goes into 29. So I would say that this number is prime. All right, it's only divisible by 1 in itself. Let's go to 27. Well, of course, 1 goes evenly into it. 2 doesn't. But if you think about 3 times 9 is 27. That means there's another number besides 1 and 27 that goes into it. So this is not prime. All right, 27 is not prime. A number that is not prime, we call it composite. It's a composite number. All right. Just so you will know a list of some prime numbers, I'm going to write some. The smallest one is 2. We have 3, 5, 7, 11, 13, 17, 19, so on and so forth, all right? It's going to be very valuable for you to know some of these prime numbers as you continue in your mathematical studies. What we're going to talk about now is what we call the prime factorization of a number. Prime factorization of a number. And basically what the prime factorization of a number is the process of rewriting a number as the product of its prime factors, all right? Rewriting a number as the product of its prime factors. That's why this list of prime numbers here is so important, all right? We want to be able to rewrite numbers as a product or multiplication of its prime factors. The tool that we're going to be using to help us do that is called a factor tree, all right? Let's look at an example of how we do that. All right, we have 2 examples here. I want to find the prime factorization of the following numbers. First, we're going to start with 84. Okay. Now, I'm going to use a factor tree, right? 84 is going to be on the top of my factor tree, all right? What I'm going to do is I'm going to start dividing or seeing if I can multiply two numbers, one being a prime number and one being another number, not necessarily prime, that'll give me 84. Well, my smallest prime number is 2, and since that's an even number, I know 2 goes evenly into 84 42 times. So I get 2 times 42. Note here that 2 is prime. 42 is composite. So my stem of my tree is going to continue under the 42, but it's going to stop under that 2. Now I'll repeat the process over again with 42. Well, since 42 is even, I know that 2 goes evenly into it. 2 times 21. Again, 2 is prime, 21 is composite, so I'm going to continue there. Now I'm going to go to 21. Well, since that's an odd number, 2 does not divide evenly into it, so I'm going to go to my next prime number, which is 3. 3 goes into 21 7 times. All right, notice 3 and 7 are both prime numbers, so 84 can be written as 2 times 2 times 3 times 7, and this is what I call the prime factorization for 84. All right, let's look at 63. All right, so I'm going to start my tree. 63 is going to be on the top. 2 doesn't go evenly into it, but I think 3 goes evenly into it, and it does 21 times. All right, 3 is prime, 21 is composite, so I'm going to start that process over again under 21. 3 goes into 21 7 times, and so 63, notice that they're all prime, is going to be 3 times 3 times 7. And I'm sorry, I didn't state this. I'm getting these prime factorizations as the bottom of this tree here. All right. And for same thing happened for 84, the bottom of my tree. If I multiply those things, 2 times 2 is 4, times 3 is 12, times 7 is still this 84 here. Right? Same thing here. 3 times 3 is 21. Or 9 times 7 is that 63 there. So I'm just rewriting this as a product of prime numbers. All right, let's continue. Now we're going to get to fractions. Now that we know factors, prime numbers, and all that good stuff, we're going to look at fractions. All right, and basically fractions is a way to write, right? We have whole numbers, right? And so what we want to be able to do is look at numbers that may not necessarily be whole. And one way to write those numbers is as a fraction, all right? The parts of a fraction include the numerator, which is your top number. Okay, numerator is the top. So in this case, it's 16. And your denominator is your bottom number, which is 25. Okay? What we want to be able to do before we start adding, subtracting, multiplying, and dividing these fractions is to be able to simplify them. Now, some of you may already know how to simplify a fraction. By all means, stick to the method that you know of. But what I'm going to do is I'm going to give you a method that'll work every single time, no matter how big or small your number is. All right? So let's talk about simplifying fractions. First thing I do when I simplify a fraction is I find the prime factorization of both the numerator and the denominator. All right. After that, I rewrite those in my fractions and I cancel my common factors. Let's look at an example. All right, we have 72 divided by 90, or 72 over 90. Right. So again, I want to find the prime factorization. I'm going to see that 2 goes into 72 36 times. 36 is not prime. It can be written as 2 times 18. 18 can be written as 2 times 9. And 9 can be written as 3 times 3. We're running out of space here. And so 72 can be written as 2 times 2 times 2 times 3 times 3. Okay? I'm going to go to 90. All right, with 90, I'm going to go through the same process. All right, 2 times 45 is 90. All right, 3 times 15 is 45. 3 times 5 is 15. And so 90 can be written as 2 times 3 times 3 times 5. All right, so now I have my prime factorization. What I'm going to do is rewrite 72 over 90 as the prime factorizations, right? So I'm going to have a 2 times 2 times 2 times 3 times 3, right? That's the same thing as 72, which I have right here. And I'm going to divide that by 2 times 3 times 3 times 5, which is my prime factorization for 90, all right? Now, when we divide something by itself, we say that they cancel, all right? And so I'm going to cancel my common factors here. There's a 2 here and a 2 here. 2 divided by 2 is 1, right? So they're canceled. This 3 and this 3 cancel. This 3 and this 3 right here cancel. And so my result, when I simplify this, is going to be 2 times 2, right? 2 times 2, which is 4 over, the only thing in the denominator is 5. And this is how we simplify using this method right here. Okay. The last thing we're going to talk about are what we call mixed numbers and improper fractions. All right, mixed numbers are numbers that can be rewritten as the sum of a whole number and a fraction. For instance, if I have a number like 3 1/2, right? All right. Instead of writing that plus right there, we have 3 1/2. We kind of don't write the plus. It's kind of understood to be there. But that's a mixed number. And this occurs when we have numbers that are larger than 1 and we want to write them as a fraction still. Improper fractions are fractions where the numerator is larger than the denominator. All right, the numerator is larger than the denominator. An example of that, 7 over 4. All right. We can also write whole numbers, as improper fractions. For instance, 3 is the same thing as 3 over 1, right? Anything divided by 1 is itself. And so what we want to be able to do is change mixed numbers to improper fractions and improper fractions to mixed numbers. Let's look at some examples of that. In this first example here, we have 57 over 5, and I want to change that to an improper fraction. Well, in order for me to do that, I'm going to have to figure out what my whole number is, right? And if you wanted to, you could use long division to divide 5 into 57, right? It goes in at most 11 times with the remainder of 2. So if I want to write this as an improper, a mixed number, it's going to be 11 and 2 over 5, right? This is your remainder. And this is your divisor. All right, and this, once again, that's your quotient. All right, but this would be our final answer, 11 and 2/5. All right, let's go the other way around, looking at 8 and 1/6, changing that to an improper fraction. All right, the way we do this, I'm going to write this a little bit bigger, 8 and 1/6. All right, we take our divisor and we multiply it by our quotient. All right, so I'm going to get a multiplication there, and then we add the remainder on top. So I'm going to have a 6 times 8 plus 1 all over my same divisor, my same denominator. When I simplify that, I'm going to have 48 plus 1 over 6, which is 49 over 6. All right, and this concludes our video on an introduction to fractions.